So this is the last lesson of the unit, and we're going to be talking about yet another couple of different formulas you can use to find sums of series. Now, they're kind of interchangeable with the sigma notation we learned last lesson, but if you had a calculator without sigma notation, which was kind of the case for years and years and years, this formula is super quick. Also, as I said, if you have to do sigma notation by hand, it takes a while. This formula is also easier by hand. So first off, we're going to look at a couple series, and we're going to talk about the fact that, well, if we know all the numbers, we could just type them directly in our calculator. So for a short list, finding the sum of the series by typing each number in the calculator can be useful. So if I type them all together, I would end up getting 242. And just to review vocabulary, a sequence is something that just has the commas between it. As soon as we're adding those terms together, we call it a series. Now, from the last lesson, it says express the sum of the series using sigma notation, and then we can use our calculator to find the sum. Now, I'm still at that computer, if you watched the last set of videos, where I don't have a calculator on this computer. So I'm just going to say you would type it in a calculator. So here we're going to do sigma notation. The things we need to identify first is what type of formula to use. I notice this is a multiplying pattern, so it's geometric. And we are multiplying, the common ratio is 3. So if I wrote my formula out, my a sub 1 is 2. My b value is 3 to the n minus 1. We are starting out with the first term, and we are adding up to the 1, 2, 3, 4, 5, fifth term. So if I was to type that in my calculator, I would also get 242. Now, this method becomes much more useful as we do larger sums with more numbers, because even though it takes a little while to write the formula, that would be quicker than typing a list of 200 numbers in my calculator. So our last way is letter C, and we're actually going to come back to this after we look at the formulas below. So let's scroll down. And we notice that there are formulas we can use for this. So we will be coming back to this, okay? And I actually noticed that there's a typo on this one, so let me just fix that. Okay. So let's scroll up. We're going to do parts A and B. As I said, we know there's formulas we're going to be using, but we're going to do the same 2 steps for the arithmetic sequence we have here. So the first thing we're going to do is add them on our calculator. So if I directly typed these in my calculator, I would end up with a sum of 50. Then we're going to express the sum of the series using sigma notation. So we'll write our sigma. We notice that it is arithmetic, and the number that I'm adding the common difference is 4. So my formula, similar to mx plus b, is d times n minus 1 plus a sub 1. So we have 4 times n minus 1 plus a sub 1 is 2. Parentheses. Here we once again have 5 terms. So we're going from 1 to 5. And if I type that in my calculator, I would also get 50. So looking at these new formulas, and as I said, I do understand that since you have sigma on your calculator, it might seem unnecessary to have other formulas, but we do have to learn these too, and just realize that there are more direct ways without sigma to find the sum of a series. So here's our arithmetic formula, here's our geometric formula, and I just changed that one part, right, so that it's going to work correctly. So we need 1 minus b, not a 2 down here. So we're going to go up to the geometric one. I'm going to write down the formula first. So our formula is S sub n. So this is the sum of a certain number of terms, is a sub 1 minus a sub 1 times b to the n over 1 minus b. So when we do our sequence, this is going to be called S sub 5, because I am adding up the first 5 terms. So first 5 terms of this series. So S sub 5 is a sub 1 is 2. And this 2 minus 2 doesn't become 0 because the second 2 gets multiplied by our b value. We're multiplying by 3. The n value is 5 over 1 minus 3. That's 1 minus b on the bottom. So it happens to be negative 2 in this case, right? So when I type that in my calculator, that is going to give me also 242. So this is called the geometric series formula. When you see that you have to use that, this is the formula you would use. It's not something you have to memorize. It will be given to you during your tests. So down here, find the sum of the series using the series formula. Now we'd have to use this formula. So there's a different formula for the arithmetic series. Now, a little different here, I have to actually put a sub n here. So we'll talk about that. That's a little tricky to find at times, and we have to make sure we know what it means. So let's copy the formula up since it's our first time using it. So here, because there are 5 terms again in this sequence, we are also calling this S sub 5. So the n is 5, a sub 1, and let me just scroll up so we can see this a little better. A sub 1 is 2. Let's erase that so we can see it a little better. So a sub 1 is 2. A sub 5, right, the last term, so this is always the last term, is 18 over 2. So if I typed that in, basically that's 5 times 20 is 100. 100 divided by 2 is also 50. So this formula will give me the same answers as the other two. At times, when we just have a dot, dot, dot here, and it says we have to add up maybe the first 10 terms, we do have to find this value. We always have to find the last term in the sequence for this formula. It does not show up in this formula. So here's our two formulas. What I want you to do is write them in sigma notation and then also try finding that value with the geometric series formula so you can check your work because you should get the same answer with both. So I'm going to suggest pausing the video and doing exercise 3 and exercise 4, and then you can come back and I'll go over those. Okay, so with sigma notation, we have a geometric series, 8 terms. First term is 3, and the common ratio is 4. So writing our sigma notation, I'm actually going to start here. Since I know there's 8 terms, we're adding up the first to the 8th term. We are starting with a 3, multiplying by 4 to the n minus 1. So that's my explicit formula that I put next to my sigma notation. If I type that in my calculator, I would get 65,535. So as a side note, if you don't have a graphing calculator, that's kind of hard to do. It's not like every calculator has sigma notation. This formula, the geometric series formula, though, you can type on pretty much any basic calculator. So writing this out, we're using our S sub n formula. And once again, I have the wrong thing here. So sorry about that. Let me get that in the right spot. So because we have 8 terms, I'm finding S sub 8. A sub 1 is 3. R, or the B value, common ratio is 4. The N is 8. And then we have over 1 minus B, which is 1 minus 4. This should be a B here, sorry. Sometimes we use R, but we're not using R this year. So if I type that in, 65,535, same answer. So let's look at exercise 4. This one is arithmetic. 12 terms, first term is 3, and common difference is negative 2. So write my sigma. Since we have 12 terms, we know we're going from 1 to 12 for the plugin. My common difference is negative 2. We multiply that times n minus 1 plus a sub 1 is 3. And we'll put our parentheses in. So typing that in, that would give me negative 96. Now, this is where the arithmetic series formula can be a little tricky because in that formula, we have to find the value of a sub n. So let's just write in what we know. 12 terms, so we're finding S sub 12, the sum of those first 12 terms. My n value is 12. I know a sub 1 is 3. Here we have to find a sub 12. So I'm going to write that to find it, because here, if this is a 12, we're putting the last term, or a sub 12, in that spot. This is all divided by 2, so we need to find that. Now to find it, I'm basically just going to use my formula for a sub 12. So I already kind of wrote out that formula, right? That's my a sub n formula, and we're going to plug in a 12, okay? So I'm going to have negative 2 times 12 minus 1 plus 3. So the 12th term in this series, we're decreasing, right? So it makes sense it's negative in this case, is negative 19. Now, if I type that in, I'm also going to get negative 96. Now, what's kind of nice about the arithmetic series formula, even though it's a little trickier to do because we have to find a sub n, is we get to hone in on finding the 12th term. Finding the 12th term is different than finding the sum of the first 12 terms. So the 12th term, the 12th number in my list is negative 19, but if I add up all the numbers up to the 12th term, I get negative 96. And that's what's different about this formula versus the formula we used at the beginning. So we're going to do these last two, and then we have a couple word problems, so these two are going to go on this video. You can use whatever method you want for these. So it doesn't say you have to do the series formula or sigma notation. You just have to find the sum of those terms. So why don't you go ahead and try those? I am going to use the series notation or the series formula because it's new, okay? But you can use whatever you want. So now that you've done these, first off, I'm going to figure out how many terms I'm working with. So this is a multiplying by 2 pattern. So if I write in those terms, I have 1, 2, 3, 4, 5, 6, 7, 8. So I'm finding S sub 8. A sub 1 is 6, so we do 6 minus 6 times the B value is 2. We're multiplying by 2 to the n, which is 8. And then I have 1 minus B on the bottom. So if I type that in, I get 1,530. On the next one, where it's arithmetic series, we do need to figure out how many terms we have going on here. There's going to be a bunch to list out. So we're adding 4, right? Okay, so there they all are. If I counted them all up, there are 16 of them. So I'm doing S sub 16, which equals n, right? So this is, I'm just going to write it n times a sub 1 plus a sub n over 2, right? That's our formula. So 16 times negative 10, this time we do have the a sub n, but the last one is 50 over 2. So when I type that in, I'm going to get 320 as the sum of those terms.